What's up, guys? It's Mr. Bringle, and today we're going to be going over the concept builder from physicsclassroom.com, charge and charging. So this is static electricity. So this first level is pretty simple, and I'll go through 3 or 4 of them here and let you finish the rest. But it says a vinyl golf tube is positively charged. What can be inferred about the relative number of protons and electrons in the golf tube? So if it's positively charged, that means that it must have more protons than electrons. If it was neutral, they'd be equal. And if it was negatively charged, there would be more electrons. So we're looking for the one that says the number of protons, the P with the positive sign, is greater than the number of electrons with the negative sign. Okay. And that's all this trophy really has you do. So this one says the foam square is electrically neutral. So if it's neutral, that means that the protons must be equal to the electrons. And this one says the stirring rod is negatively charged, and therefore we will pick the one that shows that the electrons or there's more electrons than there are protons. All right, since we've done one of each example there, we'll go ahead and stop right there. We'll move on to the next level. You guys can finish that on your own. So the second one focuses on how these charges move. So this says 2 lab partners are doing a static electricity investigation. They begin with a neutral pop can, so protons and electrons are equal. After conducting the procedure, they observe that the pop can has become charged positively. Which statement accurately explains how this happened? So a couple things here. Remember, and hopefully you've discussed this in your classroom, but the protons are bound within the nucleus. Protons are located inside the nucleus of an atom, and the nucleus has these pores that allow things to go in and out, but they're small, and the protons are too big to get through the pores. So the protons cannot get out of the nucleus. They're stuck in place. They're never going to move. Electrons, on the other hand, are located in valence shells that are outside of the nucleus, and they can move. So whenever something changes its charge, it is a result of electrons moving, never protons. So automatically, you can go in and eliminate the 2 answers that say anything about protons being added to or removed from something, because the protons will not move. The only way that this occurs is if electrons are added to the object or if they were removed from the object. So since this says that the pop can was neutral, meaning that the protons and electrons are equal, and then becomes charged positively, that means that electrons had to leave the can, and that way there are less electrons than protons. So that's the answer that we're going to choose, is that electrons were removed from the object. Okay. And I'm just going to leave those slashes there because the only 2 options are these 2 right here. That's automatic. So once again, it says the object is neutral and it ends up becoming charged positively. So it's the same situation. The only way for that to happen is if electrons are removed, because let's say that you have, let's say that it's 10 protons and there are 10 electrons initially. And then after some electrons leave, so these, we're going to get rid of some electrons. You still have 10 protons, but you might have, say, 5 electrons instead. And that's how you end up with the positive charge there. Okay. So we'll get rid of this here, and then we will choose our answer and move on. Okay. This one says we have a negatively charged aluminum pie plate. So it starts with a negative charge. So if it helps, we can do, so there's protons, there's electrons. Let's say that there's 5 protons and there's 10 electrons. So that would be a negatively charged pie plate there. Okay. And then it says that it becomes electrically neutral. We know that this number over here is not going to change. Okay. So this is before, this is after. So the proton number cannot change. We can't add or subtract protons. So the only thing that we can do is we can get proton or electrons that leave. Okay. And then we are left with 5 electrons and 5 neutrons, which would leave it as neutrally charged or no charge. So again, electrons had to be removed from the object for that to happen. Okay, cool. We'll go ahead and move on here. And I'm going to go back and cross these out because the protons don't move. So it says a positively charged pop can initially. So initially, it's going to have more protons than electrons. So let's say it's 10 protons and 5 electrons. And then it becomes electrically neutral. So we know that the protons are going to stay the same. We can't change that number. So the only way to make it neutral is to add, right? We have to add 5 electrons here to get 10. So that means that we will choose the first option, that electrons were added to the object. Okay. All right. Good deal. Okay, so we've done 4 of the 6, so I will go ahead and let you guys finish those out. Just kind of use that process there of looking at how many or you can just make up a number of protons and either set the electrons equal to, more than, or less than, depending on how the object is initially charged, and then figure out how to alter that by removing or adding electrons. Okay. Now we'll go ahead and get into the last level, which could be a little bit challenging. So this says 2 students are experimenting with 2 objects, a neutral aluminum pie plate and a positively charged metal sphere. So the first thing, we're going to stop right there. We're going to be able to answer this part right here. So it says that the pie plate, which is this guy right here, is neutral. So that means that the protons are equal to the electrons on the pie plate. And then it says that there's a positively charged metal sphere. So that means that there must be more protons than electrons on the sphere, okay? It says they momentarily touch the metal sphere to the pie plate and pull it away. So when you touch the objects, there's going to be a transfer of electrons. The pie plate becomes charged positively. So the pie plate started neutral, and now it's positively charged as more protons than electrons, okay? And then it says the metal sphere remains positively charged, but has less of a positive charge than what it had before. So it stays positively charged, but it's not as positive as it used to be, okay? So now we need to decide, how did the pie plate become charged? So it started neutral, and now it has more protons than electrons. Remember, the only way for this to happen is for electrons to move. So when these 2 objects touched, what happened is there was a transfer of electrons from the pie plate to the sphere. So because of that, it went from being neutral to having more protons than electrons. And since electrons were added to the sphere, it becomes less positively charged. So there weren't enough electrons added to it to either make it neutral or make it negatively charged, but there are enough to reduce the positive charge. So the point here is that the electrons were removed from the pie plate. Okay. And again, we can just cross out these answers here. The protons added, protons removed, never going to happen. Okay, so let's go ahead and check our answer here. Okay, great. So go ahead and continue on. So it says 2 students are experimenting with 2 neutral objects. So we know right off the bat that both of these things are neutral. A foam square and a sample of animal fur. They rub the 2 together and the foam square becomes charged negatively. So we know that we have more electrons than protons in the foam square, and the fur becomes positively charged. So we know we have more protons than electrons in the fur. Okay, so let's think about how does this occur? If they both start neutral, and then the foam plate has all of a sudden a negative charge, and the fur has a positive charge, then that means that the fur had to lose electrons, right? So it reduced the number of electrons. Now there's more protons than electrons, so it's positively charged. It transferred its electrons over to the foam square, which would now have more electrons than it had protons. So this says, how did the foam square become charged? Electrons were added to it from the fur. Okay. All right, we'll do one more and then I'll leave you with the last one to do on your own. So this one says two students are experimenting with two objects, a neutral aluminum pie plate, and a negatively charged metal sphere. So this one here. They momentarily touch the metal sphere to the pie plate and pull it away. The pie plate becomes charged negatively. So now we have negative charge over here. The metal sphere remains negatively charged, but has less negative charge than what it had before. So it's still negative, okay? It says, how did the pie plate become charged? So the pie plate was initially neutral, and then it becomes negatively charged. So the only way for that to happen is if there are electrons that are transferred from the sphere to the pie plate. Okay, it has to gain electrons here. So if the sphere was initially negatively charged and then it loses electrons, this is just implying that it does lose some electrons, but it doesn't lose enough to make it neutral or to make it positively charged. It just loses a few electrons. They go over to the pie plate. The pie plate becomes negatively charged because it was initially neutral. Okay, so how did the pie plate become charged? Electrons were added to it. Okay, so I'll let you do that last one on your own there. And that would be the charge and charging concept builder from physicsclassroom.com. Make sure to let me know if you have any questions.